read Advent of Code, day 12. I am streaming. Let's go. Yeah, still haven't got around doing part 2 of day 10. Still traumatized. Let's do day 12. And yeah, I'm still sick, so that's why I have a blanket around my neck. And I kind of look like, I don't know, like those rich women in the Victorian century. I think that, like when they have like huge fur coats and they also have a fur, I don't know, stuff around their neck. That's what I look like, but it doesn't matter. You finally reach the hot springs. You can see steam rising from scheduled areas attached to the primary or the ornate building. Ornate. I'm really bad at English, huh? Ornate. English. Ornate. Ah, ornate. Okay. Ornate building. Okay. As you turn to enter, the researcher stops you. Wait, I thought you were looking for the hot springs, weren't you? You indicate that this definitely looks like hot springs to you. Oh, sorry, common mistake. This is actually the onsen. The hot springs are next door. You look in the direction the researcher is pointing and suddenly notice the massive metal helices towering overhead. This way. It only takes you a few more steps to reach the main gates of the massive fenced-off area containing the springs. You go through the gate and into a small administrative building. Hello, what brings you to the hot springs today? Sorry, they're not very hot right now. We're having a lava shortage at the moment. You ask about the missing machine parts for Desert Island. Oh, all of Gear Island is currently offline. Nothing is being manufactured at the moment. Not until we get more lava to heat our forges and our springs. The springs aren't very springy unless they're hot. Say, could you go up and see why the lava stopped flowing? The springs are too cold for normal operation, but we should be able to find one springy enough to launch you up there. Yeah, I don't get... Okay, they need lava. There's just one problem. Many of the springs have fallen into disrepair, so they're not actually sure which springs would even be safe to use. Worse yet, their condition records of which springs are damaged. Your puzzle input are also damaged. You'll need to help them repair the damaged records. In the giant field just outside the springs are arranged into rows. For each row, the condition records show every spring and whether it is operational or damaged. This is the part of the condition records that is itself damaged. For some springs, it is simply unknown whether the spring is operational or damaged. Okay. However, the engineer that produced the condition records also duplicated some of this information in a different format. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in order in the order those groups appear in the row. This list always accounts for every damaged springs, and each number is the entire size of its contiguous group. That is, groups that are always separated by at least one operational spring would always be 4, never 2, 2. Okay. Excuse me. So condition records with no unknown spring condition might look like this. Okay, that's fine. However, the condition records are partially damaged. Some of the springs condition have actually unknown, for example. Okay. So we know that this one is working, and this one is not, this one is not. I guess, and yeah, this one is working. That makes sense, I guess. Equipped with this information, this is your job to figure out how many different arrangements of operational and broken springs fit the given criteria in each row. In the first row, there is exactly one way. Separate groups. Ah, okay. Or this one could be working, this one could be working, and this one could be working. Okay, so there is one. There's only one way, yeah. And there three broken in that order can appear in that row. The first three unknown springs must be broken, then operational, then broken, making the whole row this. So is more interesting. It could be a total of 4 different arrangements. Oh, can there? Because that's definitely a tree. Ah, yes, because it can be there or there, and here it can be there or there, so 4 possibilities. Okay. The last 4 must always be broken to satisfy the final contiguous group. Okay, I think I understand. The last line is actually consistent with 10 different arrangements. Okay. That looks recursive. That looks recursive. Since the first group is 3, we definitely know that this is constant. And we definitely know that this one needs to be broken since they cannot be, like each of these is definitely contiguous. Then, okay, and the 2 is, okay. And then we know the 2 there, we definitely know that there is one space there. And then we need to do some kind of loop for the next ones. So we have to keep track of the one we already fitted. So in this case, we already fitted 2 and 3, and we can completely disregard all of this, or even all of this. And then it's just a matter of fitting the group 1 into this. And I think we can simplify this by recursively trying to fit one in this, then going to fit that in this, then to fit that in this, and then there is only one possibility, which is this one. And then you go up the stack once, and you just put the one wherever you can in the first spot that you got. And then you pop the stack up into the 2s, and then the next possibility for 2s is this. Yeah, that looks very, very recursive. Okay. For each row, count out the different arrangement of operational and broken springs that meet the given criteria. Okay, and the puzzle input is this. Okay. And so this can be something. This is the example. Okay. Might as well get the input now. This. Okay, we'll run this. Just example. Then we do 4 line in strings, split line iterator of S. And then for each line we need to get Springs. That's a space. That's I don't know, records of strings partition, a new partition line with a space. And let's print strings and records. Boom. That's correct. And let's just do combination counts. It's a proc that takes springs, which is a string, and it takes records, which is a slice of integers, and it returns an int. And then we do I'm not sure. Actually, let's call this record string, and then let's record is equal to strings split, just split record string with this. Can I shadow with a different type is equal to slice, let's see. Slice is slice map. Is there a mapper? Slice mapper takes an S, which is a slice, and a procedure, and returns. Oh no, okay. Turns a V, and it returns a V, so it looks like it. And that takes records, and that's a proc that takes a string and returns an int and returns strconf a toy of string of s, and we have to import strconf. That doesn't work. Cannot determine polymorphic type. Or else yes, exit. No, okay. Forgot what the type is. It returns this or an error. Let's see. Re-declaration of record. So yeah, I cannot do this. Records split. Differ, delete, record, split. Sorry. Oh, okay, that's good. And this is what I want. Yes, it is. Let's put that on multiple lines. And I should do this as well, I think. And so here we will have a sum equal to 0. And here we will do sum plus equal combination counts of springs and records, like this. And we will print the sum. Okay. So Mm. Then we do a switch on springs 0. And we can do if len springs is equal to 0, we return 0. Yeah, that makes sense. Or len records is equal to 0. Yeah, if we don't have any records or if we don't have any springs left, there is no more combinations. Yeah, that makes sense. And they want to count the different arrangements. Yeah, they call it arrangements. So let's call it a arrangements count as well. To be in line with the problem description. Switch spring 0. So if it's a dot, we know it's empty. If it's this, we know it's functioning. No, not working, working, and unknown. And so if it's not working, do we actually need to do anything? Not sure. If it is working, can we do return arrangement counts of springs like this? We skip one. And can we do records 0? No, actually. It's function and then records. And that's it. Or is it? Yeah, no, we need to do records 0 minus 1, I think. Yep. Do, 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 do. Look at the example. So here we start with a question mark. And then we need to check that putting a functioning one here is valid. And for that we need to just capture the number of... Okay, so let's start with this. So if it's a question mark, we do count operational, how do they call it? Operational or damaged. Operational And then we do for springs for C I don't know, S in springs do if S is equal to this. We need to do if it's different. And we need to start at 1. If it's different, do break. Otherwise, we do count operational plus equal to 1. Is there a slice count? Yeah, but that doesn't break at some point, so yeah. Count operational. And so we have the number of operational just after, and we do if records 0 record 0 plus wait no minus current operational is equal to 1, we can replace it. So we can do springs 0 is equal to this. So in this case, let's see, where is the example here? So I will have count operational to 3, and then here I have a 3, and I do if 3 minus 3 is equal to 1, then we can replace it with functional. Otherwise, we cannot. But if this was a 4, I could do this is 3, and then we do 4 minus 3, which is 1, and then we can replace it. So yeah, okay. So we replace it, and we return arrangement counts of springs, and we can skip all the we can skip the current one, and we can also skip the operational ones, since we know they're part of a group. And then we can do records, and we start at 1. And of course we do 1 plus, since we found one arrangement. Every time we pop something from records, we know that we need to do +1. And then else there is no +1. We didn't find anything. And we know that springs 0 is a dot. And we can just go to the next one. Cannot assign to spring 0. Can I do springs equal to springs? Cannot assign to spring 0? Why? Why? Maybe I need to convert the string to an array of runes, to a slice of runes, like this. And can I do strings? Rune? How do I say contains index, right? Wasn't there like UTF-8? No, it's TRG UTF-8. Strings to runes, yes it is. So it's day 7. So it's this. And rune. Where? Here. It's this. And I just need to have this here. Up, like this. Okay. So that's the whole logic for a question mark, I think. That's the whole logic for a question mark. Yeah. Now we need to do this one. So here we still need to count the number of operational, I think. And if the count of the count of operational. Yeah, but that logic is a bit is not complete because that only takes into account if there isn't like any operational before. We need to take also into account if there is like a bunch of operational, then a question mark. And if this is the case, we need to, I think we need to keep track of it. Previous operation count, which is an int, and is equal to 0 by default. Okay, so let's have a count operational procedure proc that takes springs and which is a rune and just returns an int, and which is this. Up. Yes, I think we want this. Return count operational. And so here, count operational is okay, let's just call it C. C count operational of springs 1. Okay. So we need to again see count operational here, and we need to do if the number of count operational after. Actually, this time it's not after, it's just here. If the number of count operational plus previous operational count is equal to records 0, then we need to return a +1 because we're gonna pop this. And here we need to do just count operational like this, I think. Else we didn't find an arrangement, but actually that should be impossible, shouldn't it? I'm not sure. I'm not sure. That's okay, I think. Also, I think I didn't thought about this, where there is like 4 question marks. I need to, instead of popping the records, I need to decrease it by 1. Oh, this is tricky. This is tricky. Can we start with a simple case first, where it's like damaged? And if it's damaged, we can reset the previous operational count and just go to the next one, right? I think so. So this is just return arrangements, and we can just do springs, the next one, and keep the records, and the other one will be 0. So that's okay. Then let's assume question mark unknown cases don't exist yet. Let's assume this doesn't exist yet, and we just have a function to verify that it's correct, to verify that the record is correct, and it should always return 1 arrangement. And actually, this is bad, huh? Because like I'm counting the number of replacement I make. Or am I? I'm not sure. Anyway, yeah, this is not great. Oh là là. So we do operational count, then this will always be 0 for now. Then we do if it's equal to records 1. If it's equal to records 1, we do this, we skip all the lines of operationals, and we pop one of the records. That makes sense. Huh. And if it's actually not correct, if it's not correct, we need to set the previous operational count to C. Skip to C also. And do this. Because if there is like a question mark just after the operational, we need to keep track of that there was operationals before. So that's okay. Okay. And next, this one. And I'm gonna take a small break. All right. I am back. So if there is a one in an unknown state, we indeed still need to count the operational after. And let's change it with count following operationals, because it's the one after. Then if the current record is equal to, actually it's not equal, it's lower than, wait, no, because operationals is not question marks, it's just that. Actually, I don't know what I'm doing, because this just means that there is a fork in the road. Like in the springs. Fork in the springs. Because that just means it can be damaged or operational. So we need to do arrangement counts when it's operationals. So like this. And then we do springs, just springs, like we pretend that it's operational and count the possibilities, and with the same number of records, and then we pretend it's damaged, and we do the same. And we do just for the sake of bad naming, just C1 and C2, and we return C1 plus C2. That should be it, no? Like I don't think this whole logic should be there for the question mark, for the unknown. That does make sense, though. Do you think here we need to do previous operational count plus 1? Like this. And we don't need to count the following, like keeping track of in the previous is as well enough, I think. If we do if previous operational count plus 1 is equal to records 0. And let's flip this around because it sounds better in English, I think. If the first record is equal to previous operational count plus 1, we know there is like 1 plus it's this, I think, no? And we don't need this, just go to the following one. Yeah, and this can be reset to 0. I mean, the previous operational count can be reset to 0 here. And the problem is we cannot like make them continuous, so we have to skip one. I mean, skip one more. Can this just be 2? I don't think it can. Let's remove all this. So I think this is like perfect, don't touch it. And this, this is okay. Okay, but we just need to take, I think this is fine as well. I think we just need to find a way to make sure that you cannot like put two records next to each other. And I think this will go away as well. So if it's... And yeah, let's make this complete by doing else. So here we found one combination, and then here we can do... And there is only a +1 here, but that's where the arrangements will be counted. So we need to basically count +1 every time we pop one. And since this kind of like fork will like duplicate the path that we choose, it will be +1, but yeah, that should be okay. I mean, that was the worst explanation ever. But so if it's not equal, we just go to the next one. We don't pop the records and we do previous operational count +1. Do I just need a flag that says we already popped a record just before, so ignore the current one? Let's see what it does currently. Well, it does 8 on the first one, which is not great. Let's not care about this. And let's print springs like this. So it starts off that way, then it fills this one. Then it advances here. Then it fills this one. Then it goes here, and it fills this one. Ah, yes. And how many times does it yeah, like how many times does it do +1? Indeed. So here it does +1, which makes sense. And also here and here. That's quite strange. That is quite strange. Do. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Why? So record 0. We need to print record 0. Records 0. Record 0 is equal to 1 here. Yeah, okay. But previous operational count is equal to... yeah, okay. Yeah, okay, so I do need the next one to avoid like... Okay. Actually, can't I do it like this? And we would have something here. So... Wait, I'm getting confused a bit, but... Uh, can we maybe move this up, like here? So if record 0 is this, then we do +1. And we reset the thing. Yeah, but here, what do I do? Do I just have no condition? So we go to the next one and increment it by 1? Oh, nope. Nope. And we never come here. Never come here. Let's print previous operational account and records here. That's getting a bit messy, but so in this case, and then we transform this, and previous operational count is equal to 1. Oh, actually, we shouldn't increment it by 1 here. We should not increment it by 1. And here, we shouldn't reset it. Actually, 1 is correct in this case. But I mean, this is the easy one, so... and let's, just for now, not sum it up. Actually, no, there is 4 possibilities here, so that's already not correct. Here there is 10 arrangements, and no, it didn't found this. Okay, but he found this one. And I'm slightly confused. Why is there a 3 here? Oh no, that's the previous operational count. That's not arrangements count. And here I'm not counting actually the arrangements. I'm just counting when we manage to insert one record. So how do I count the arrangements? That's a bit tricky, I feel like. That's slightly tricky. Uh-huh. And also, this is not completely correct because it should be the same as here. Like, if you already have 3 before, we need to have this condition as well. Yeah. Yes. the if this that works. Uh, but I mean, none of this matters because I think I have the right logic to like go over all the arrangements, but I have no clue how to actually count them. So actually maybe instead of returning an int, I need to generate slices of runes. Runes slices. And then do a unique on them and count that. Is there a slice? Is there a slice? Oh. Slice. Unique. Compare, sort, zero, swap, fill sort. Last, first, equal, reduce. All of length. Uh, Actually, we know we have a new arrangements when records is equal to 0. So this is 1. So if records is equal to 0, we know we have a new arrangement. And it's definitely not when we have this. And then we need to count the last one. So there is this as well. If it matches, again, no plus ones. We need to pop the records. But here the problem is that the string can be wrong. So that's a bit tricky, huh? That's a bit tricky. I guess we can just have an exception for this, maybe. If springs is 0, I mean, we don't want to return 0, but we... Hmm. if springs is different than 0, we do this. Else, do this. It takes out of range. $35. Oh, here. Ah, yes. I mean, if there is no more springs, there is no more arrangements possible, right? Okay, that's messy, but okay, one. So he counted this one. This one is supposed to be 4. Yeah, that doesn't look good. So again, let's only take into account the first first element. So 0, 0, 0, and then here it becomes, oh wait, no, that's previous. And just for debugging, I would like to origin, I mean, that's gonna be a bit annoying, but origin, just to have a nicer print. And at the very beginning, we do so we have origin and we have origin like this. Okay. Yeah. In a comma. And here, instead of printing spring, we print origin. Okay, that looks correct. I mean, that looks like about what I want it to look like. And can I do a join? Strings join. Okay, so I can just do strings join of this, and we join it by nothing. I cannot assign value origin to a table to string. Strings join safe join. Can I do in origin do print r like this? Alright, that is what I want. Maybe this as well. Up. Okay. So, yeah, that is the original one. Then it's gonna put the first spring here, and I would like to do here, I would like to print something to say when println new range that we found a new one. So yeah, this is the arrangement. So this is actually correct. And it's still going to explore the rest. And I think it's exploring it correctly. So here he already found it, but he needs still to go over the last those ones, I think. And yeah, then here he found this one. Then here it's counting one by one the last one, and then it reaches 0. And this is empty, and there is a new arrangement. And here it tries all possibilities, but the records never goes empty. That's good. Then I would like to do I would like to skip the first one. Can I do cat example and then just copy this? Again, terrible debugging code, but what can you do if springs equal to this? We continue, so continue, ignore the first one. And so this is the second one. Okay, so here it found only one arrangement, which is incorrect. But why? Why is the question? So he starts here, and then here this is actually correct. He found one arrangement, but then so he continues here and here. Oh wait, that's weird. That's weird. Like then it replaces this, but here it's just a dot. Huh. So when it backtracks, I need to replace it back with a... Okay, so yeah, I need to put back the question mark where it was. Otherwise it cannot backtrack. And there is 4, and that's correct. I think. Let's see. 4 is correct. Alright, so let's remove the print and see. And let's remove the break, and let's remove the continue, and let's print stuff. 1, 4, that's correct. This is 5, this is incorrect, it should be 1. This is 1, this is correct. This is 4, incorrect, this should be 4. And this is 40, but it should be 10. So the first 2 are correct, and then the last one, the third one is incorrect. And my guess would be that currently I'm allowing contiguous stuff, because it's always more, right? I mean, I'm not showing this to the stream, but this should be 1, and actually I have 5, and at the end there is an insane. So yeah, I think it's not considering that it needs to skip 1. How do I do this? So I need to make sure that if so this is this condition is only triggered here. I need to make sure that if there is a this, I need to assert that the next one is a dot. Ha. It's getting trickier. It is getting trickier. I mean, doing Advent of Code when you're sick is not great, but anyway, there's this syntax that is not supported by the syntax highlighter. Is there an update? Update sync. Oh well. Oh well. Maybe first let's verify that it's actually what I'm suspecting it is. So let's break here this and let's have another case. So the second one, it's actually good. So we don't care and we want to paste it here and we want to do this. Okay, so that's the one that ends up in 5. And yeah, it's concatenating all of them, which is not correct. Okay. Actually, maybe this condition that I have here and here to like pop a record, for this one it's correct, but it should only be correct if it's a dot, so if there is a non-functioning one, or it's the end of the string. So if it's this, and len springs is equal to 0, then we can return this. Does that make sense? It does not. It does not. 35. So here. Yes. I just need to do this, I think, because it's gonna just going to fall here after. Oops. And it's 1 at the end. All right. Okay, let's remove the prints. Let's remove the break and the continuous. Let's see. Oh, I forgot one. This one. So 1 4 1 1 correct. This is not correct and this is not correct. But okay, I'm making progress. This one is one. Those two are correct now. What could be the problem with this one? So there is a 6 and there is a 5. And it should be 4 arrangements because it's this, or this. And it's counting 9 of them. How can it count 9? That's strange. Huh. let's paste this, and if it's different, we continue. Okay, and let's huh. Oh wait, what the fuck? It's concatenating them again. Why is it allowed to do that? Da, da. Why is it allowed to do that? Oh no, actually it's fine. Yeah, of course it's allowed to do that as long as it doesn't count the new arrangement. So, okay, so it doesn't find anything. Then it goes all the trees, doesn't find anything. All the twos, doesn't find anything. And here he found a new arrangement, which is really strange. Because he found this one. Yeah, okay, so I need to... So right now, if he fills something with a... Fuck, I hate the way that Tmux does this. So right now, here he counts this, because it's basically ignoring the first two every time, I think. So it backtracks just enough to like put this to like a damaged one, and put this one to like an operational one, and it just discards the first two. But actually, we need to keep track that there is like those two are not validated. Those two. How do I make sure? I think that when I reset the previous operational count, so that's when I discard this information, I should have a check. And if this check doesn't pass, I don't do the recursion. So here I I discard the previous arrangements and here, but I think this one is the problem. So, should I even do this? Like, maybe I should do this only if previous operational count is greater than is equal to 0. Because if there was already one operational before and we didn't find a match in the record for it, we have to disregard it, I think. 4. Yay! That's the correct one. 4, and let's remove this and the prince. Okay, 1, 4, 1, 1, 4, 10. That's exactly what I want. Let's go. And then I need the sum of those, which is 21. And here I just do a plus, and I do a empty println part 1 sum 21. Yes, sir. Input. Let's see, is this correct? I feel like there is maybe a tricky condition that I didn't check, but yeah. Fuck. This is the right answer. Your answer is too high. Too high. Let's keep track of this. Too high is this. Yeah, for this one there is only one, that makes sense. For this one I think there is like 1, 2, 3, 4. There's 3. Is there another example by any chance? That's the only example we have. Huh? That's the only example we have. But I thought this one was wrong in my case. Like I think this is supposed to be four arrangements, but we got 3. So let's test with this, and let's do strings is equal to this. Again, this is very, very messy. Break. Let's just disregard this. Let's just disregard. Ah, fuck. I just need to do 9 is this, and it's 1, 3, 2. So number of arrangements is 3, but I feel like this is wrong. So there can be ah fuck. Okay. another, as a cool kid say, bio break. Boop. Okay, let's just manually list all the possible combinations and see why I'm wrong. So I just need this and like this. So, oops. So I think one of the possibilities is we have this, and this is popped. And then the tree has to be there. And the tree is popped. And then the 2. Oh, wait, does it? Can there be this? Like, if there is a lonely one here. I don't think that's possible. So it can be like this. Or, both of those can be there. And, no, because there needs to be a 1 and then a 3. So this is always like this, and this is always like this. This is good, right? So yeah, I think there is only 2 actually. So before we, because the thing why we have 3 is because it's allowing this, which is not correct, because you have a lonely one at the end, which does not match in the list. Which that is incorrect. So we have to, when this is hit and we have a new arrangement, we first need to check all the other ones. So if slice any of in springs is of type this, we do return 0. Otherwise, we return 1. Does that work? Does that work if I do this? And I run it on the example. Wait, what? 21. I run it on input. I get a number that is slightly lower. Let's try this one. Yeah, and let's check that my example is actually correct. So now this one should only be 2, and it's 2, okay. Yay, right answer. All right. It took me an hour and a half for only part 1. Fuck me, and it's only day 12. Ah, it hurts, it hurts, it hurts. Yeah, before I clean this up, let's read part 2. But actually, I think if I remove all the garbage, it's not too bad of an implementation. I think I can already remove this, and origin can be removed at the end, so this will make it a lot cleaner. All right, let's drink some water. As you look out at the field of springs, you feel like there are way more springs than the condition records list. When you examine the records, you discover that they were actually folded up this whole time. To unfold the record on each row, replace the list of springs condition with 5 copies of itself separated by question marks, and replace the list of contiguous group by damaged springs with 5 copies of itself separated by commas. So for this row, it would become this. So yeah, basically they want to make the recursion explode, which is not nice. So this would become 5 copies of itself. Replace the list of springs condition with 5 copies of itself separated by commas. Okay. Oh, okay. So 5 times this. 1, 2, 3, 4, 5. And then this is like 1, 2. Okay. Oh, fuck. Okay. The number of possible arrangements for some rows is much larger. Okay. Do I have to make my nice recursion into a loop? That would be unfortunate. Okay, I mean, let's try the dumb way first. I don't know the maximum stack size. I think if you type ulimit, you can have it. Ulimit a stack size, maximum stack size of it's in kilobytes. 8 meg. That sounds enough. But maybe I can also modify it. And also maybe there is a custom stack size limit in Odin. Not sure. Let's first try it on the example. And we just duplicate it by 5, which shouldn't be too hard. So we do. Unfolded records is make of int And this is 5 times length of records. And you do 4 4 I in unfolded records do unfolded records I is equal to records I modulo len records. Okay. And let's fmt print len unfolded records. That sounds about right. Yeah, 5 times what I want. Yeah. And let's do the same thing for the springs. So, O2, yeah, very, very bad naming. Oh, unfolded, folded springs is equal to make a list of rune, a slice of rune that is 5 times the length of O. And then we copy this, and then it's unfolded springs, and here as well, and here it's O, and it's length O. And I want to print unfolded springs as well. Does that look correct? Yes. Oh, wait, no. There's supposed to be... Ah, it's separated by... Okay, yeah, okay. It's to be separated by things, so unfolded springs is +5. Is there a slice join? Slice join. Concatenate. And that's not really what I want. Count proc clone to dynamic. I need to put a hoodie on. We need to do if I modulo 5 is equal to 0. Do this is equal to question mark, else do this. This will get shifted by 1 every time as well. We do plus plus this. Ah, Shouldn't it be modulo 6? So let's strings make rune of length. So it's 5 times this. It's plus 5. Huh. Come on. What is it? If I do 0 modulo 5. No, that's 0. I think this needs to be I plus 1. Oh, or I minus 1. No. No, that makes no sense. So it's if... I mean, it's something modulo 5. But it's not I, because I isn't related to like the modulo. Maybe it's if I modulo length of O is equal to 0, we do this. Every time it has reached the length we want it there, and then we do I plus 1. And I is inferior to len unfolded springs, and we do I plus 1 here. That doesn't sound correct, but let's still print it. So it starts with 3 and then it messes up. There is actually an empty one here. You know what? Let's do it the dumb way. For the springs, x is equal to make this rune, and then we do there is 5 of them. And then we do for AI in 0 till 5. Do x as I is equal to make rune of length O plus 1. Then that one is fine. Actually, it's only splitted, so it's 4. And we do like no, we can just do do this. We can do slice, fill. Ah no, copy. Isn't there like a copy? Okay, yeah, that sounds right. And we copy to x's I from O, and we do x's I, and then length of, so the last one is equal to this, yes, and then we do unfolded machin, strings join, it needs to be a strings. Now we can do slice concatenate of x's. Yeah, let's. I'm too lazy to do it the clean way. And we finally do unfolded springs is equal to unfolded springs. And we just ignore the last one. Up, len, like this, like this, like this. Let's do. Uh, 79. Nice. This needs to be -1. So 3, then 3, then 4, then 3, then 4, then 3, then 4, and at the very end it's supposed to be 3. So it's not -2, it's -1. And at the end is 3. Yep, that is correct. And the other is correct as well. And now let's comment this out and do and so origin unfolded springs, same thing here, and unfolded records. Let's call this with an S. Yep, unfolded records. So one that is it is almost correct. It's like -1 this, and let's stop printing this. Why is it printing the normal ones? I'm confused. Oh, and I'm printing the sum, okay. So this is correct, 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 and what I had just before, this is a correct answer for the wait, no, for the example. Yes, and I'm really not sure if I need to optimize this. Yeah, there is ones that are like way larger than the one in my example, so there is also 1,000 of them. But let's try it. Maybe it will work. Or maybe it won't. Yeah, it seems to be at 100%. And it just is spinning. That's not great. Is the first line of input so bad? Oh. I don't know. The fact that it's 5 times the same thing should help me in some way. Maybe I should keep a cache. Would it help to have a cache? Like as soon as I find an arrangement. No. Huh. Yeah, I'm not sure. Okay, this is taking like a really long time. Mm, I don't think I can do it the dumb way. Fortunately. Where's my tea? Oh, okay. So yeah, that won't work. Oh, maybe O speed. Maybe O speed. How to make this faster? And I don't think it's, I mean, it's obviously not as easy as just doing time 5 every time. But yeah, I feel like we could reuse the results that we get since it's 5 times almost the same thing, but there is like the question mark between them that is tricky, and also the fact that they're next to each other, which creates more combinations. So you cannot just do like this number of combinations exponent 5. Yeah. It does feel like it's all related, no? Like if I do Python 3 and I do, what was it? 4 exponent 5. No, okay. The 10 exponent 5 looked related, but... I think it's like minimum this. It's minimum this, but there is a lot more combinations. And why would a cache not help? Maybe because we... I don't think we revisit the same combination twice. Yeah, since there is no like moving backward, we never go to the same position again. Hmm. But I'm very surprised that like this one is taking like an infinite amount of time. Am I printing? Yeah, I'm printing every time we have one, so it should be... So the first one is taking a huge amount of time, this one. But like in the example, this one, which has like a shit ton of unknown as well, took just... It was instant. And there is, I mean, there is a lot of them, huh? Let's just, for the sake of sanity, let's just do if springs is equal to the first one. Continue. Let's ignore the first one and see. Ah, so okay. So it can then it reaches this one, and then there is this one with a lot of question marks. But yeah, it's a huge amount, and there is like 1,000 of them as well. Oh là là. Yeah, it's already in the billions. No, that's it. Still in the that's 100 million. I am printing the sum, that's why it's always so large. Uh, how do I prune? How do I visit less node? How do I visit less node? Oh là là. Is there a way to split the problem in simpler chunks? Is there a way to split the problem in smaller chunks? Like we get this, right? And we already know the answer for this one. Wait, what? We know the answer for this one. I mean, if we take the even simpler one, we definitely know the answer for this one. And if we know the answer for those ones, uh, I feel like this one is, alright, this one is really easy to understand because it will always be one, no, nothing, one, and then it's always this tree, and then it's always this one you cannot, so it's always, yeah, it's always the same pattern, so there is no, like, explosion of combinations in this one, and same thing for this one, huh? Uh-huh. Do 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 do. And yeah, this time there is no way to just. I mean, there is an easy way to make a thread pool and do them 16 by 16. I think that's what I have, right? I have yeah, 16. But I think my stack is gonna explode, and there is no way to SIMD. So yeah. And the thing that makes them explode is here, because it splits into two, and then yeah, it's like a fork bomb. But is there a way to say, like, is there like some condition that says if something like we only explore this branch if something? Is there a way to return early? Is there a way to return early? Or maybe some more things like this. Like we just do a linear thing on the springs, and like we already know that if there is more active springs and we don't have any more records, we know that it's a bad one. We know that it's not an arrangement. What else do we have? We can do the sum of the active springs and the... Can we do like count plus slice count springs question mark if this is inferior to slice sum. Isn't there like a sum? There's a math sum, I think. Math sum of records. So if there isn't any more, if there isn't enough things like this, if there isn't unknown plus active too much what we have in the records, we can do return 0, I think. And we can import. And that's already wrong, so no luck. Shouldn't that be correct? If the count of active and unknown is below what we need to have, to do like count this if this is greater than mass sum records. We can already return this. The same as before, but I would assume slightly faster. Let's do an example to check that I have the correct response. That is indeed correct. Not sure how much faster this is. But then I do this and it's not correct anymore. Plus. So we have the total number of springs that we need. And if this plus this is below this, we know we have to return 0. Why isn't this correct? Why isn't this correct? Maybe I need to do this there. No. What? Ah, maybe I need to do as well previous operational curves. And that is correct, but it doesn't seem a lot faster. That's just like a very small trick. There is no speed benefits, I think. Yeah. There is no speed benefits. Oh, I think we have one more now. What was the result above? No, that was a bad one. That was 32, then this, then this. This looks about the same. 14, 28. Yeah. After 14, 28. Yep. It's about the same timer. Maybe slightly faster. Because we reached that one, I feel a bit faster, but not that much. Not by that much. That's still not good. Can we do the first one? No, we cannot. Also, that might be actually slightly slower because computing more things. Maybe I just let it run all night. No, let's not do that. I don't think I need this anymore. I need a smarter way. I need a smarter way. So this doesn't really matter. Okay, let's steal the good answer. I mean, I'm looking for branches to trim, but and oh yeah, I saw one thing that so in the Odin calling convention there is always a context that is passed, and maybe that's slowing the recursion a bit, so I can have a context-less procedure. Yeah, implicit context pointer. So yeah, or there is a fast call or fast. Let's try that, huh? I don't think that's it, but like, still fun to experiment with it. Oh. Context has not been defined within this code, but is required for this procedure call. What was it if? Ah, so the standard library needs a thing. That's unfortunate. What was it? Slice. I think it's count. Yep. Can we just do for I in from 0 till for c is equal to 0 for I in strings if s is equal to this do c is equal to we do just c. Actually, we can directly return 0 here. That is a good answer, and it is indeed. Seems faster, but not sure. And this is fast call. That works as well. Yeah, again, don't think this is the way to do it, but yeah. Let's ignore the first one, which was this. This? No. Yes, this one. Yes, indeed, that looks a lot faster. What if I remove the origin? I think I can do like s origin this by nothing. This. So it was 19 seconds to reach the 11711. And this time it's a bit faster. I definitely need the rest of the arguments. And I'm confused about this. If record is equal to, we can pop the record. You know, it makes sense. It does make sense, but do we need it? Since we do it just above. No, I think we need it there. And I should check this first. This is going to be false more often than the second one. If otherwise, return 0. Yeah, that's about the same. That is about the same speed. Uh, Whoops. Bu- 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 bu. And contextless is the same as fast, right? Yeah, it's about the same. Uh, yeah, it's really this one. It's really this one. Is there cases where I'm 100% sure that a question mark isn't going to be branched? There might be. I mean, it's not just for the question mark, but like simple one would be if previous operational count is greater uh, than records 0, we can return 0. No? If what we have before is greater than what we can have, we know it's not possible, right? Yeah, okay, that doesn't speed things up as much. Oh, it does. A little bit. Okay. It does by a little bit. Maybe let it run a bit more. Mm. Hmm. Yep. Uh, I wonder if there is a still a sound on the live. Still a sound. Yes, there is. Yes, there is. Yeah, okay. But the solution is slightly faster, but not that much. Not by that much. I really don't see the. No, I really don't see the trick. I really don't see the trick. Maybe we can make it slightly faster, but by copy pasting the logic here. But again, that's like a very stupid trick. It's not like an algorithmic trick. Like we can basically skip a recursion. Skip like one call in the recursion. But yeah, that doesn't seem faster. That doesn't seem significantly faster. I feel like a smart mathematician could figure this out with without any recursion and just doing some multiplication and factorial stuff. Uh, is there an algorithm to, because what we want is basically all the combinations, but with a restraint. Combination with How do they call it? With a predicate? Predicate. Predicates. Combinations count with S train. Determining combinations with restraints. With restraint, here's a specific issue I'm having. Number of objects in it, number of state is 2. Number of black object, white object, how many unique permutation color permutation are possible? There is a minimum of No, the mic picks up on that. My bad. Permutation. Way to orange colors. Officer into the combination. I'm shaking. Different ways of picking. Getting two heads. Depends, lottery, probability. Maybe. The thing right now is what I'm doing is I'm basically generating all the possible combinations, and I just cannot do that. There is too many of them, and I have a formula to like compute how many I can have, but then I need to discard some of them. And I think what I could do is like concatenate all the unknown and then generate all the combinations for those and then put them back where they belong and like filter them. But that would still that would still mean that I'm generating all the combinations before filtering them. Ah, number of K combination, example counting combination, number of combination with repetition. Example of counting multi-subsets. Number of ways to put objects into bins. Combination can also be thought of two sets of items, those that go into the chosen bin and those that go into the unchosen bin. This can be generated with a number of bins. With any number of bins, with the constraint that every item must go to exactly one bin. Multinomial coefficient. Coefficients as a product of coefficient. Block design. Multiset. Multiset is a modification of a concept of a set that, unlike a set, allows for multiple instances for each of its elements, number of instances given multiplicity. Okay, so it's just a regular array. Multiset. Okay. I need to K1. Where n is the number of items, m is the number of bins. Ki is the number of items that go into bin I. Okay, I know what Ki is. It's just like the concatenated number of unknown. And n can be the total, but like we have multiple n's, so that sounds weird. Yeah, no, that's not it. You know what? Let's ask ChatGPT. In mathematics, is there a way to get the combinations with a particular restraint? I mean, yeah, I can do yeah, I don't think that's possible actually, because yeah, this is just some multiplication, you know? So I need to look at very specific examples every time. Can I compute the number of combinations that are restrained by just modifying the springs? Oh. Blow my nose. Doo-doo-doo-doom. Yeah, I'm pretty stuck. I am pretty stuck. I am pretty stuck. Let's quickly go back to the idea of having a condition in the unknown state. A condition in the unknown state. I mean, there is two ways of looking at this. Either we keep looping over every single possibility, but we find way to quickly discard stuff that we know is bad, but we still need to generate about here it's like a lot, huh? Like it goes from 14 million to, yeah, we need to basically loop over 100 million things, which even if we find the exact perfect way of generating an arrangement, would still take 100 million like iterations. So we have to do some numbers tricks, I think. I mean tricks, mathematics, but I call them tricks because they often look magical to me. But so it has to be some kind of formula, I feel like. Or it could be a mix of both. So like if suddenly here we can say that number of arrangements from here is I don't know, like 1,000, we could suddenly return 1,000 instead of returning one. Would there be a way to do this? And one of the, I don't know, one of the optimization still for only generating them would be to make tail recursive, which is currently the case, almost. It's just that this is not tail recursive. because a tail recursive function can be optimized into a loop, and that makes it a lot faster. Could also make it into a loop, but that sounds pretty hard. Let's maybe make sure that the only reason it takes time is because there is a lot more combinations. T1 is equal to... Is there like a time thing? In order time... See, time... Ticks? Stopwatch? Stopwatch duration... Can I do stopwatch is equal to, so it's core time. Time stop, just stopwatch like this, and then time stopwatch start. It's this, and then stopwatch stop, and then stopwatch reset, and we println the time taken, time stopwatch I don't know, time stopwatch what? Stopwatch duration. Okay. Okay, so there is a time just above. So this one took 5 seconds. And yeah, so just the more there is, the longer it takes. I mean, it obviously makes sense, huh? But just wanted to make sure. Uh, oh, how? I feel like I'm hitting the brick wall of mathematics. Uh, uh, yes, this is a staring contest between me and the problem. I'm gonna win. I believe in myself. uh, fuck. Uh, let's see. Uh, fuck. Store valid combinations. Yes, that's what I am doing, kinda. Except, I mean, I'm generating and applying the condition as I go. But yeah, I'm generating only the one. Yeah, okay. I'm generating them one by one and and checking the condition at the very end. And I'm already doing something to like prune the bad item. Right. So if this is this one. And just out of curiosity, if I do this, that makes it slower. Yeah, okay, a lot slower. I mean, yeah, and this would make it even slower. Oh no, that makes it faster. Okay. Oh wait, what? Okay. So fast makes it lower. I'm getting a bit confused. Let's wait for the big one. No, fast makes it faster. Okay. uh, when we could push the insanity by generating bit masks for like damaged operational and unknown, but yeah, again we would still just run into the fact that we have to generate a lot of them. Uh, ha. So I cannot generate all the possible combinations. Am I printing? No, I'm printing it after. Let's print this just before. And let's print the sum here. And the one that took a long time so if there is a lot of question marks and a lot of 1, because a 1 means that it's gonna do the combination of all of those. And here there was a lot of question marks, but it's 8 and 5, so that restrains it quite a bit. So it's only if there is like small records and a lot of question marks. Because here there is like small records, but not a lot of question, or like the question marks are splitted by active ones. But if they have a lot of question mark combined next to each other, like in this case, and ones and small numbers, can we, if we have a continuous, I mean, it's not a very generic way of optimizing things, but if we have a continuous run of unknown, if we have a continuous run of unknown, we just count the number of unknown, and we just do the math combinatorics thing. That becomes really, really trickier. I mean, this we already know it's a 3. And here we have to fit a 1. But the thing is, we have 2 ones. So we could compute all the combinations for 1 into 4. But we have 2 into 4, and we have a condition that they cannot be contiguous. But it could also just be 1. Like there could be like a 1 in any of these, and then a 1 here, and then a 3 here. That's also fine. Or there could be a 1, nothing here, and then a 3 anywhere here. But if we put the next one here, we know that this is the number of combinations here times the number of combinations here. Is there a way to have a combination formula that, so we do, like, if we disregard the 3 here and the first 3 here, and we just have this, is there a way to, like, try combinations just in this slot of 4, we try combinations for 1, we try combination for 1, 1, and we try for 1, 1, 3. For 1, 1, 3, we will have 0. Is there a way to have weights? Because those are like kind of weights. I mean, maybe the combination approach is a dead end as well. But let's say I consider only the number 1 to make it simple first. Is there a way of giving it this and then doing all the combinations of just a 1 and then all the combinations of 1, 1? Like the number of them. So in code, it would be, I can cut this. It would be something like this. Known count equal to 0. Do break here. Whoops. Unknown count is equal to 1. And this is a question mark. And we would do just if unknown count is greater than, I don't know, 2 and records 0 is a 1. We do combinations is equal to factorial. I don't remember the thing, but it would be an count divided by factorial of something. Okay, but then it gets even trickier because yeah, 'It's really tricky, huh? Ah. But I don't know. I feel like if I'm doing something too complex like this isn't in the spirit of what is asked from those kinds of puzzle. There is generally one clear, simple solution. And if I stack conditions on top of conditions with a huge spaghetti code, it just won't work. But maybe this idea, because I'm doing this for like 1, but is there a way to generalize this idea to take into account numbers that are higher than 1 and And here. Well, first there is a problem of like they have to be separated by something. So if there is like 4 question marks and you have a 1, like you can position them here, here, or here, here, or here and here. So that's 3 combinations, but you cannot like make them next to each other. And the way to do this, wouldn't it just be to remove 1 for each number -1 that we have? What are the number of combinations of 2 into 3? Combination calculator. Let's say 2 into 3. What? This is the opposite, so 3, 2. That is 3. I think that makes sense. So this is correct in my case. Let's see with a more complex example. What if I have 5 of them? So it's all of those. And then it can be here as well. Or it can be here. Or it can be here. I think that's it, huh? 1, 2, 3, 4, 5, 6. 6 and so it's 3 into 4. That's 6. Okay, so I know how to handle the fact that they cannot be contiguous. You just do -1. Handle can't be contiguous. Just what is it? Objects. Objects -1 minus len records, like this, minus len records -1, like this. So for each object we have to remove 1. Because here if we have 1 more, like we would need 1 more space. And so we will need to like go back to 6 basically. Actually that may not be right, huh? So let's see. I would have to remove 2, and so it would be I don't know, we can have this, and that's it. Yeah, and then we would remove 2, so it would be 3 into 3, and that would be just 1. So that's fine. Next, we have the fact that it's not always 1. It can be 2, so there is a weight associated with S, associated with each what do they call it? Sample. Is there a way to weight samples in combinatorics? Some samples take more space than others. There is a concept known as weighted combinations. Oof, that looks heavy. Oh. Weighted combinations, where the weighted permutations, so we can already disregard all this. Ah man. There is nothing better than cold tea. When dealing with combinations of permutation, there is a concept known as weighted combinations or weighted permutations. This concept involves assigning weights to each element or sample in a way that reflects its importance, size, or significance. The weights indicate how much space or significance each element contributes to the overall combination. As a basic explanation of how you might incorporate weights into combinatorial calculations. For weighted, you would assign a weight to each element, and the total weight of a combination is the sum of its weight of its element. Combination weighted NK, the sum of each combination. See each element, the product of each element when I belongs to C weight I. Total weight combination N is the total number of elements, K is the number of elements I to choose, W is the weighted assigned to element I. Wi is the weight assigned to element I. Okay. The summation over all combinations of size K from the set of n elements. Let's try to. Can you explain weighted combinations in the lay? How is it spelled? Layman's term. Layman's term. Layman's term. Combination. Yes, that I know. Suppose you want to find total weight. Their weights is multiplied together, so for each combination you calculate the product of the weights of the chosen items. So for each combination you calculate the product of the weights of the chosen item. Combination apple banana product would make 3 times 2. Yeah, but that, to get the total weighted combination, you sum up the product of weights for yeah, but that's not what I want because he just gets the combination and then no. Product of weights is just an item. Is that alright. This all feels too complicated to be the right answer. Alright. I think I'm gonna stop here. One more day where I cannot do part 2. 3 hours and a half. It hurts, but oh well. But oh well. I think there is something to this, huh? But yeah, cannot figure it out. Or not today at least. And I'm hungry. So yeah. Can I still do this? Okay, yeah. Alright, anyway. See you tomorrow. Still part 1, huh? So it's not a complete failure. And yeah, tomorrow day 13. Let's go.